Hello, this is the 4 Simple Gas Law Notes version. We're going to go through these very quickly. Hopefully you've already done the pressure. You've looked at how we convert pressure, what volume will be measured in, and temperature. That's critical before we begin these. So looking at a problem with Boyle's Law, we're going to look at 4 laws again. We've got pressure 1 times pressure 2 equals pressure 1 times volume 1 equals pressure 2 times volume 2. As pressure goes up, volume goes down. So this is called inversely proportionate. Please try to keep that in mind as we go through the problem. We'll check it at the end. So first thing I like to do is when I read the problem, 1.2 ATM, that's going to be P1. Label it. 2.8 liters, that's V1. Label it. 1.8 ATM, that's P2. So there we go. We've got them labeled. Find the new volume. I come up to the top, make sure I've written my formula, and then I circle which one I'm looking for. That's very critical. So now I'm ready to, what I do, call plug and chug. We plug in the numbers. That's my P1, my V1. And then we put in our 1.8. And then an X. Now how do we solve for the X? This times this divided by this, and that gives us 1.9 liters. If you're thinking, wow, are gas laws this easy? Yes, it is. If you're good in algebra, you're really going to love gas laws. Well, that was Boyle's Law, inversely proportionate. Let's check it before we leave it. So we got a volume that's gone down, so the pressure should go up. Did it? Yes, it did. So we know we're right for Boyle's Law. Charles' Law, notice we've got some new letters here. We've got volume and temperature. Notice on the side it says temperature in Kelvin. Has to be in Kelvin. So as I read this, you'll notice something that I do every time I read it. Given a balloon at a temperature of 27 degrees C. Ah! The reason I scream is to remind you, when you see the C, add 273. Notice I'm adding before I even label it. So that new temperature is now 300 Kelvin. And volume of 750 milliliters is heated to 37 degrees C. 273, 310 Kelvin is my T2. All right, now we just plug and chug. Volume 1, we find it, 750 milliliters over our first temperature, and that's going to equal some new number we don't know. Let's let X be that, and 310 Kelvin. Now, notice here we're going to cross multiply and divide. The Kelvins cancel, and you're left with, I think, 775 milliliters. Here, when temperature goes up, volume goes up. So let's see, temperature went up, volume went up, so we know we're right. That's it for the first 2 laws. And you may need to stop these or replay them if you want to hear them again. Next law, yes, it's really his name, Gay-Lussac, I'm guessing French, learned about pressure and temperature. And they're also directly proportional. So when one goes up, the other goes up. Temperature is still in Kelvin. So we'll go ahead. I did try to throw you a curveball on this one, so let's see if we can work it together. Metal container. So that means that the volume doesn't change. Keep that in mind. So the atmosphere pressure goes from 0.93 ATMs to 27 degrees C. Why am I screaming again? When you see the C, add 273. Again, 300 Kelvin. And that is your T1. We're going to be looking for a new pressure in a second, so we're going to go ahead and label this guy P2. Got all our pieces together. Let's go ahead and plug and chug. 0.93 ATM over 300 Kelvin equals, we know the pressure, but we don't know that final temperature. When you work that out, you get 580.6 Kelvin. Yay, I'm done. No, you're not done. it says degrees C. What's the opposite of add 273? Subtract it. And your final answer, if I can do the math, 307.6. Almost did it. Degrees Celsius. Okay, that's our final answer for Gay-Lussac. Again, pressure went up, temperature should go up, and it did. 7.6 degrees. Sorry about that. We'll let you focus in on that. So hopefully you see why I subtracted, because the question asked for degrees Celsius. You cannot keep it in degrees Celsius. Remember that. It has to be converted and then converted back. You must do that to get the right answer. Last gas law is the hard one, but it's actually the one that is kind of the originates all of them. If you cover the temperature, you've got Boyle's law. If you cover the volume, you've got Gay-Lussac, and you cover the pressures, you've got Charles. So you have all three gas laws here, thus the name combined gas law. So let's see if we can read through this, and then we'll plug and chug again. You have a ball with a volume, V1. Pressure, P1. Temperature, are you ready? Temperature of 28 degrees C. Again, 273 when you see the C. So that's going to give you, I think, what? 301 Kelvin, and that's my T1. If the ball is taken outside in the summer, it's going to get a lot hotter. The new pressure is new pressure, P2. Temperature, degrees C, 273. Add that up, I think you get 360 Kelvin, and that's your T2. Find the new volume. So looking up at the top, I haven't been doing this, but on this one it's very important. Circle what you're looking for. That way you know you're trying to solve V2. And now let's plug and chug, and we'll put an X there. Where's my P1? There it is, 1.1. Putting the units really helps you make sure you know what you're doing. ATM, from your last video you learned, was pressure. 2.25 liters, that's obviously your volume. Next, your temperature 1, which we look up here is 301. Now, what are we going to solve that? What are we going to set that up to? If I can pull it over here, I have to add some more white paper. We need a P2. Where's our P2? There it is, 1.4 ATM. And we've got X, some number we don't know. Sorry, I ran off the paper there, didn't I? And lastly, what is my T2? And that's that 360 Kelvin. Now, I have a lot of students that can get to this point, and they don't know how to type it in. Cross, multiply, and divide works well. This times this, divided by this, divided by this. And that would solve for X. And when you type all that in, you get 2.1 liters for our final answer. Make sure you type that in and can get that answer. All right, if you have any questions, be sure to email me any of those. If we need to set up a Zoom class to give any tutorials, we will. But again, if you're good in algebra, this was probably really, really simple for you. All right, so we'll finish up here, and the homework, you'll have 5 problems very similar to these. Email me those as soon as you get them done. Thank you.